Let's consider now an electrolysis cell. And here we are taking a reaction that's non-spontaneous and forcing it to occur using an external power source. So let's first consider a spontaneous reaction, and this is with our zinc oxidation and copper reduction that we've looked at before. And this is our simple electrochemical cell. Now, as written, this is a voltaic or galvanic cell because this is the spontaneous process. And E standard for the cell is positive, 1.1 volts, so that makes delta G spontaneous, negative. And here, zinc is going to zinc 2 plus, copper is going to from copper 2 plus to copper metal, and the electrons are flowing from left to right. And on the left we have the anode, and on the right the cathode. So this is a spontaneous process. This battery will run until we either run out of zinc electrode, because here the zinc electrode is being consumed, or through the Nernst equation, the concentrations become such that we will suppress the cell potential enough that it will go to 0. So if we want to run this reaction backwards, we're going to have to supply an external power source because it's not spontaneous. So what we could do is we could connect the anode and cathode to an external power source. So say we have a battery, and if we connect the cathode to the positive end and what used to be the anode to the negative end, now we'll force electrons to flow in the opposite direction. So now electrons are flowing from right to left. They're being pulled to the positive end and pushed out through the negative end. And so now copper will be oxidized and go from copper to copper 2 plus, and zinc will be reduced, going from zinc 2 plus to zinc metal. And E standard for the cell, for this electrolysis cell, is negative 1.10 volts. So we're running the reaction backwards, so we just change the sign on the standard cell potential. So since it's negative 1.1 volts, our battery has to be greater than 1.1 volts in order to drive the reaction backwards. So this way, we can use an external power source to force the reaction in the non-spontaneous direction.